I'm Benjamin Serra, North American Sales Manager at WARDJet. Thank you for joining us today for our most recent installment in the WARDJet webinar series. Today we're going to be talking about 5-axis cutting. More specifically, 5-axis cutting with our WARDJet Apex 60 cutting head. Now, Jeff Day, our Senior Application Specialist, is going to cover a variety of topics on 5-axis cutting. When you look at 5-axis cutting, there's a lot more to consider than just 3-axis. In addition to an A and C angle, you also have to consider how are you fixturing material? How are you going to present that material to the cutting head? And what effects will that have on your overall part quality and dimensionality? Jeff's going to cover two main topics today. One being how you can configure a different tooltip into your 5-axis head in order to increase your reach and overall effectiveness of your 5-axis cutting head. We're also going to look at the relationship between your tooltip offset from your material and how that can ultimately affect both the quality and, again, dimensionality of your part. If at any time over the webinar you have a couple questions, feel free to put them in the chat box below and we'll make sure to cover them afterwards. So with that, Jeff, take it away with the demonstrations.
We'll go ahead and walk through how to program a fixture and the 3D part in iGEMS. Go into the 3D 5X area here. And first I'm going to open up my blank and I'll use that to create my fixture. This is the shape that we'll be trimming around, and we're going to create a fixture to support this while we're cutting it. Right now the bottom of the part is right at the top of the table, so that would probably cause a collision, but what you can do is use this Z height button and you can move your model up off the table. And we're going to move it up about 1.5 inches, so I'll put the top of the model at 5 inches. And now that gives me room to put a fixture under there. Tools tab, they've got the grid button here to create a fixture. You can tell it the thickness of the material that you're using to create the fixture. We'll be using some 1/2-inch plywood. How many fins that you want X and Y to support your part. We'll do 2 in Y and 3 in X. So as you fill out these numbers, it'll show you what you've got here. You can also do things like you can move things around if you need to avoid it being cut up as much. This will be how much additional material is around the base of my fixture here. I usually like to give myself a little bit more around there. And then cutouts, we'll click on calculate so we can see what that is. Cutouts would be so water and abrasive can flow through the fixture. And then this length here refers to the length of the slots for these tabs here. So if you want more, you can increase or decrease these numbers as needed. And then you got option here for clamps. These are these fingers sticking up here. If we weren't going to be cutting down here, you could have these fingers sticking up to help position the part in the fixture and hold it in the fixture. In this case, since we're going to be cutting down in this area, we're not going to use any clamps. You can turn off the internal one, even though it doesn't really apply to this part here. And then when you got something that looks like will work for you, you can click on the export button. And this will create a 2D geometry here that we'll go back to later to create our parts for our fixture. So you can just hit enter, that'll bring you back into the 3D area. And then what we're going to do is we're going to delete our blank off of here, and then we're going to save the fixture so we can then import this into the actual part file that's got what we're going to trim here. So we'll go to our CAD tab and we'll delete that. In iGEMS menu, we'll save. iGEMS menu, we'll do save as, and we'll just call this fixture, if that makes sense. And then we can go ahead and open up our part that we're actually going to cut. And we want to have it have the same Z height. So we'll go back to our cam tab, click on Z height, set the top at 5 like our blank was set to. And then we can go ahead and import that. And then we can go ahead and import that fixture that we saved. And then just hit enter, puts it right there. So we got the same 0, 0, 0 point right now. And part of the reason we want to bring the fixture in is so that we can set a 0, 0, 0 point on the fixture. Right now our 0 point is here, and generally you're going to want to set it on one of the corners of the fixture. We've got our 0 point command here. We can choose where we want to have our 0 point, so everything will be referenced off of there. Next, we're going to pick the curves that we need, so we can add toolpaths to this. Curves button, in this case here we can do pick surfaces, click on the top surface, and if the fixture gets in the way in the lower right hand corner here, you can turn off the fixture. Still there, just hidden. And then we can click on the bottom surface. So those red lines are curves that we're then able to add toolpaths to. Click on done. And go to our toolpath area. So we're going to change our tool position to follow, so the Z will move as well as X and Y. And we'll click on our plus button to add a toolpath. We'll start here, upper curve will pierce here. Going in that direction, choose that as our bottom toolpath. Choose that as our bottom curve. And then we can give it information about the lead in and lead out. And And right now we've got 1 inch additional standoff here. So generally when I'm doing something like this for the first time, I'll add some additional standoff. And then as I get comfortable with things, can move that toolpath in towards the part. So we might start off with an additional 1/4 inch standoff. And then you can move that in closer if you need to, as you get comfortable with the accuracy of your part and your fixture. Now we could program that 3 more times like that. You can also do things like array. So we can go to our CAD tab, and then under the transform submenu, we've got polar array, and then we can choose toolpaths to array. And then as you hover around here, it'll show you different axes that it can rotate this around. And I want to rotate it around that axis. And we're doing 4 copies, 360 degrees. Okay. So very quickly, you've got your 4 toolpaths designed there. Go back to our cam toolpath. So these other 3 toolpaths are grayed, showing that these are children to the parent, which is nice because if you decide to change something on one of the toolpaths, the main toolpath, so we want to move that a little bit closer, change that, and then that will affect the other 3 as well. If you individually want to change one toolpath, you can still break this off. You can use this and split that child off from the parent, and then it's its own thing that you could individually change if you needed to. And then we'll do the outside cut. So we'll do our plus button again, upper curve. We'll start down at this corner, and we'll go in that direction, lower curve, and S for plane, because I want to basically come in on this plane here. And same thing on the lead out. Curve is on the right, which is correct for the direction of travel. Click on close. Okay, now we'll take a look at adjusting our rapids between cuts. So for example, if going from this last inside cut to this outside cut, you want to pull away a little bit to avoid any potential collisions, you can click on this rapids button here. And for example, we can apply approach retract distance to a rapid. Do say 2 inches, and then if we choose single, we can choose an individual rapid to apply that to. So left click now when that's highlighted. That adds that approach distance to that rapid there. Click on done. And then similar but slightly different, you can use this modify button to add multiple points on a rapid. If we wanted to rapid some point back here to make it easier for the operator to take this part off, put the next one on, we can use the modify and choose the rapid we want to modify. This also has a retract option here that we'll do, and we'll do 2 inches on that, which will bring us back to there. And then we can go vertical up to a point, and then we can do H for horizontal. And down here at the bottom, it shows me how far I move my mouse. So I can either just randomly click a point back here, or you can type in a specific distance and then hit enter, so it'll wrap it back to that point there out of the way. You can also control the tilt of the cutting head on a rapid. So if you want to preemptively spin the cutting head to an angle as it approaches this outside cut, we can use the vector button, choose the rapid we want to apply this to, left click here where you want it to spin around, so we'll left click here, and then you can specify angle and the C rotation for that, and click on done, and you can do a similar thing on that end rapid at the end of the cut. Do vector again, choose the rapid, and we'll left click here and specify and basically keep it at that orientation until we're safely out of the way. And done, and then same thing up here to make it stay at that orientation. And then when it's finally back here, then it'll straighten up. Done, and okay. And then we can simulate that. And if there's any concern about the device hitting your part of the fixture, you can also use a 4-inch nozzle. Right now we're showing the 3-inch nozzle. I'll show you here in a moment how we can switch to the 4-inch model. Just fast forward to the end of this cut here. So let's back up a little bit so that goes a little bit slower. Slow this down. So at the end of that cut, it's going to lift up, spin around here, and then come down and approach. And then if we just fast forward to the end of that cut, so at the end here, again, it'll pull away, maintaining that angle, and then only once it gets back to there, straighten up. And if we do want to use a 4-inch nozzle, we can close out of here, and got a machine set up for the 4-inch nozzle. In the machine settings, under the 5-axis kinematic area, we can choose which model cutting head we want to use. And go back to simulate. And then you've got your longer nozzle there. So ultimately, when you're ready to make your CNC file, click on the G1, G2 button. And we are going to be using a G54 work offset position, so I can choose that. And that will be ready to cut. Click on the create button here. So this brings us out into the 2D area. We've also got our fixture that we created here. So generally what you'll want to do is take your fixture and put that into a different workspace. I'm just going to do Control X, and I'm going to start a new workspace, and then Control V. paste that in here, and then I'm going to choose my material that I'm going to cut my fixture out of, which will be plywood, and it's about 1/2 inch thick. So now what we can do is cut this out of our plywood. We do have these identifying marks on here, so to make it easier to put the fixture together, if these pieces weren't too symmetrical, you could cut these identifying marks in here to make it easier to put the fixture together. So what we'll do is we'll program those as cuts and show you how that works. Then we can go to create and select our parts, and then if we actually want to cut that other objects, I can just select everything again, which will select the text. And then to cut those, you can use, for example, the marking tool, multi, and can either do that water only or with abrasive now since it's a marking command. You can use our contour command for the regular cutting. And then of course, if we want to nest these onto a piece of material, choose our parts, give it a sheet size, and nest. So click on stop, click on OK, cam, set your 0, 0 point, and then create your CNC file. This one here we'll do as a G92 program, and then we're ready to go. So let's go to the machine and cut.
Now we've got our part in our fixture design. I'll go ahead and cut out our fixture. I'm just using some plywood, which is nice when you're prototyping your fixture. Oftentimes when people are doing this, once they've got their fixture down, they'll make it out of maybe aluminum or stainless, or you can certainly do it out of plywood still, and then put metal in appropriate places to help protect the fixture from being cut. So let's go ahead and clamp this down. We'll cut this, and then we'll go from there. So I'm basically going to jog over to the corner of my material. So I've got my material loaded, got my program loaded, corner of my material. I'm going to turn on my pump. So we can tap up here, turn the pump on. And we're running this program with our height setter. So I can start my V at whatever height, and then it's going to go over and use the height setter to find the top surface of the material. What's doing here initially is we're actually cutting identification marks into the fixture, so when we put this together, we know what piece goes where in the fixture. We'll let that dry out a little bit, then we'll put together, and then in the meantime we'll cut our base fixture, into which we'll put this fixture so we can accurately locate it on the table. Now, theoretically I could just put this base fixture right into my, or this fixture right into my 0, 0 point on my machine, but to show you a little bit of a different concept of how you can cut another sub fixture for this fixture, we'll go ahead and do that just for the fun of it. Alright, so we've got this piece of material. I'm going to clamp this down, and then we're going to come to a corner, and we're going to start our cutout approximately here. We'll cut an opening, and this point here is going to be my G54 work offset position that I'm going to use for the program that I'm actually going to cut here. So in the controller, I'll save that position as a G54 XYZ position, and then all the coordinates for my actual program will be based off of that location. So we'll go ahead and clamp this down and cut out a little window. Alright, so we'll go ahead and move to a start point. So I've got this picture. So I've got this point right now saved as a G92 position. I'll run the Fixture program from there. And then in the meantime, I'm also going to go to my offset area, and I'm going to edit my G54 position that we'll be using. So I can click on here to edit this and take pictures of X, Y, and Z. We'll probably change the Z position later. So load our base fixture program. Water and abrasive are on, and run. I always like to zero out these coordinates down here. And basically, I think got this programmed as a press fit, so hopefully that should just basically push into there with a little bit of persuasion, and then we'll have our dome on there that we'll trim that out of. So let's go ahead and put together our fixture, and we'll put our dome on there, and we'll clamp that down and see some action. So we've got the parts for our fixture. So we got the numbering in here so that you know how this goes together. This one's fairly symmetrical, so it wouldn't make a big difference. But basically, we've got Y1 and Y2. So Y1 will go in the front, Y2 will go behind it. And we'll push that in there. Nice little press fit. And they've got X1 and X2 and X3. So X1 basically working left to right. Put that one in there. X2. See if I need my mallet at any point here. Might need to encourage that one to go in there. And then X3. Let me grab my motivation tool. So, looks pretty good. Now I can locate that on there, put a couple screws in here to keep this from moving on me. Nice thing about plywood. And we'll put a couple on the side here to keep it from spinning on me. Probably finish the rest of that on the machine. Get it started here at least. Alright, let's go ahead and clamp this down, and I think we'll be ready to cut. I may not need the motivation tool. Okay, so here we go, we'll put that in there. See how my press fit does here. Motivate that a little bit. I think that should stay in place pretty well. Just for safety, I'm going to put a couple more clamps on the side of that just in case, but I don't think that's going to move. Finish screwing that down. That should be good. Let's see. We'll just put a couple clamps on here for a little fun of it. Okay, so I've already saved my XYZ position for this back left-hand corner when I cut out that opening. Now the only thing I need to do is set my Z height 1/8 of an inch off that corner for my G54 work offset position. So I'm gonna basically move back to that position without moving down in Z, and then I'll manually adjust my Z height so I'm 1/8 inch off that corner, and that will be our work offset position. So now that we're there, we slowly jog down in Z. That looks like a good height. I'll go ahead and save that as my G54 Z height. And then we can go into our parts list and find the part that we're actually cutting. All right. So now that I've got this clamped down, we're gonna switch over to our longer 4-inch nozzle. Right now I've got a 3-inch nozzle in there. Once we've changed over to that 4-inch nozzle, then we're gonna save our G54 Z height. Want to make sure you do that after you change out to the longer nozzle, otherwise your heights will be off by 1 inch. And then we will go ahead and trim this. So let's go ahead and switch the nozzle, and then in the controller we'll tell the controller that we're using a longer nozzle, and that'll adjust all the kinematics so it knows how to position the head. Okay, we've got our longer nozzle in there, so now let's take a look at how we tell the controller that information. So basically over here, go into your parts area. Excuse me. So over here, go into your head 1 panel, and then down here in the apex area, we have the calibrate button here. Click on this. And over here, we're telling it that right now we're using a 3-inch nozzle, and we can just change that to 4, and then click on save. And now the kinematics will use that in its calculation of how to position the cutting head. So we can close that. And now that we've got the longer nozzle in there, we're going to go ahead and adjust our G54 Z height. So if we need to get into some tighter locations, especially when we get into robotic applications where something like this, customer needs to cut out coupons in various locations, 3-inch nozzle might be a little bit difficult to get into some of these areas. And we also offer a 4-inch nozzle in that situation. So oftentimes that extra inch of nozzle length gives you that extra ability to get into some of those tight areas there. Alright, so we've got our fixture in our base fixture. Now what we're going to do is we're going to move to that back left-hand corner of our fixture and establish our Z height for our G54 work offset program. So I'm just going to jog forward to that corner, bring my cutting head down manually, use my 1/8-inch spacer to establish my standoff, and then we'll save that value in our work offset position. And that looks good there. So now we'll go ahead into our offsets tab and into our G54 position. Click on the edit button and click on the camera to capture that value. Click on save. And now everything will be based off of that Z height. Now, being a G54 program, I can start my cutting head anywhere. So first cut in this program is towards the front of the helmet. So if I want, I can position my cutting head here and it'll spin around and wrap it over to that point and pierce there. We'll make sure our feed rate's at 100%. We'll go ahead and load our program. So the controller will leave that ghost image of that previous program that we cut so we can visualize that this is going to be centered on that fixture. And then turn on our water and abrasive auto buttons, turn our pump on. Okay, we're up to pressure, hit our run button. End of the program there. We've got the cutting edge rapiding back to its park position. So then that makes it very easy for the operator to take this part off, put the next part on, hit run, and cut the next one. So there you go. That's how you can program and cut a full 5-axis part on a 5-axis WATERJet. Tidal wave.
for joining us at the webinar. We hope that these tips and tricks will ultimately help you get the most out of your WARDJet, WaterJet, and ultimately the parts that you're cutting. If you have any ideas for topics that you'd like to see covered in future webinars, please feel free to reach out to us at sales@wardjet.com with your ideas.